He's going to deliver a lecture on correlation between objective and subjective methods used for video quality evaluation. So, you have how long you will need? 45 minutes,
okay.
1 hour, so it's up to you.
Okay. Thank you. So, my name is Miroslav Ugrina, and I am from University of Ljubljana, from the Department of Telecommunications and Multimedia. So, the title of the presentation is the correlation between the objective-subjective metrics, but the final will be also the added value will be how to map the objective metric into the subjective mean opinion score type of evaluation. So, first, when I start, I will say something about with the video quality and by what is the video quality affected. We know that today is the multimedia domain, and that means also the video and audio transmission and streaming has increased, and because of this increase, it is necessary to evaluate the quality of these two types of transmission. I focus on the video, so that means I will not take into account the audio domain. The video quality is affected by the resolution of the scanning part of the camera. That means what type of chip, what type of lens I use, and so on. Then also how I process the signal in the television studio. And then I think that compression technology and transmission link imperfection are the most things that influences the video quality. In my presentation, I focus on the compression technology and the evaluation after the compression. So I will not, as I said, I will not take into account the transmission link imperfection. We know that many compression standards exist, are developed and established. Not the first one, but the first one was MPG-1, but we know that MPG-2 is one of the most used, or was one of the most used compression standards. For example, in Slovakia, in DVB-T, we still use MPG-2, so for us it is maybe in television mostly used, but in many parts of television streaming, H.264 is used, in mobile devices, laptops and streaming and so on. The newest one in MPG domain, compression standard, is MPG H.265, called also HIVC. This is the newest one, and in my presentation, in my results, experimental results, or in measurements, I use this type of technology, this type of compression. These standards that I was talking about, are based on MPG, but also any other compression standards are used and exists. For example, VPA and VP9 that established and developed the Google Corporation, and also one of the newest that is not established but have been or is developed is DALA. It is developed by Mozilla Corporation and XIF Org Foundation. The establishment will be, or the head of this Mozilla Corporation said that this codec will be established in 1 year, so we will see. So these are the mostly used compression standards. How we can measure the video quality? So the video quality can be measured directly in the studio, in the television studio. For this type of purpose, we use vector scope and waveform monitor. The vector scope measures the luminance part of the signal, waveform monitor the luminance, and the vector scope measures the chrominance part of the signal. So it will be It can be in, for example, in hardware or in software. It doesn't matter. So this is directly in studio. It is not so necessary for us. For us, it's necessary when we want to measure the signal after the compression, or transmission. For these types, we use objective and subjective methods, and also one of the newest methods, the crowdsourcing. I will say about some objective metrics and subjective metrics in few minutes, but I will show you and say also on the experimental results, on the measurements that I have done. So, how the measurement was done? So first, because as I said, I focus on the compression in this presentation. So first we downloaded the test sequences in the uncompressed form from the official websites that give us the uncompressed test sequences. Then we compressed it to H.265 codec or compression standard by using the tool X265, which is directly used for compressing to this compression standard. Then we decompress it back to YUV format, but and then we compare it with reference one. This was the test sequence, and after the compression, and we compare it to reference one with some objective and subjective methods. So, which type of sequences we used? We used two types of sequences. One was the dynamic scene, or when the players were playing basketball, so we called it basketball, this type of sequence. The second one, in the slow motion test sequence, called cactus, when only the some of the train was, it's not here, but some of these parts of picture were a little bit moving. So the test sequences were in the full HD resolution, that means the high definition, with the frame rate of 50 pictures per second, and the bit depth was 8 bit into the pixel for one color. The length of the test sequences was set to 500 frames, that means 10 seconds. The duration was 10 seconds. Here you can see some options, coding options that we set for coding to H.265 compression standard. So we had to enter the input options, as I said, the resolution, the color space, the bit depth, the frame rate, and so on. Then we set the GOP structure. So how the GOP structure should look like, or will look like. We used the typical GOP, and the group of picture was typical, so the length of the GOP was 12, so that means from one iframe to the other iframe, the length is 12 frames. We use 2 B frames between each B frames. We know that GOP consists of I, P, and B frames. And in the next parameter, we set the quality. We restrict the quality by setting the bitrate, the highest bitrate. This is example for 4 megabit per second. Because 4,000 kilobit per second, and it is 4 megabit. And then we also enter the command line. We assemble the commands that set us the EUV and MP4 test sequence. Here you can see print screen from coding, yeah, in the command line. So first we done objective evaluation. So some words about the objective assessment. Objective assessment consists of use of computational methods called metrics, yeah, that measure the physical characteristics of video signal, such as signal amplitude, timing, signal-to-noise ratio. The advantage of this, of using these objective methods is that they are repeatable. They are not time-consuming methods because it's not time-consuming type of evaluation because we did it we did it on computers. So, and it is because of this fact, it is easier way how to perform that as a subjective than a subjective test or testing. So, as I said in the scheme before, we compressed to the some compression bitrate. The bitrate was set from 1 to in the range from 1 to 10 megabit per second with a step of 1 megabit. So it was 1, 2, 3 till 10 megabit per second, and we evaluate the video quality by using 3 mostly used objective metrics: PSNR, SSIM, and VQM. So, some words about these metrics. PSNR, that means or stands for peak signal to noise ratio. That it is most used, very easy to compute method. It is the oldest one, and I think one of the mostly used objective method. But we use also 2 others. SSIM, I think the best one. It is a structural similarity index. This method or metric measures the luminance, prominence, or the luminance, contrast, and structural similarity, and combines them into the one value. And this value gives us the mark that tell us how the video is good or not. Yeah, about the video quality. The worst, the 0 stands for the worst seconds. That means if the video quality is the worst, it means we have the 0, 1. When we have mark 1, it means that we have the best quality. So this is the interval from 0 to 1. But I think in any cases you don't get these extreme values. Then we use VQM, also one of the popular objective method, which uses the DCT domain to compute the visibility of artifacts. But it is a little bit more difficult than SSIM method, but gives us also reliable values, reliable results. So in these graphs you can see the experimental results. These graphs are not so important for us for this presentation, but you can see that with the increasing bitrate, the quality increases also, as we assumed, of course. We can see that the curve is a little bit exponential, and we can say that, for example, in 5 megabit per second, the PSNR is about 35 decibels. Here you can see the same results that were done using the other 2 metrics, SSIM and VQM. Yeah. So with rising bitrate, the quality rise, of course. Here you see that, for example, 5 bitrate, for 5 bitrate, the SSIM is about 0.88. Yeah, but from this graph you can't say if it is good or not for people, because for example, for TV provider, he wants to know how the people see or watch the program and what the people say. It is a good quality, not so good, or totally bad. And from these graphs, we can't say it. Yeah, we can say that for any any bitrate we have any value. Yeah, or some bitrate we have some value, but we can say if it is good, not good, and so on. Because of this, we use subjective assessment. Yeah. Subjective assessment or evaluation consists of human observers, so the people who watch the stream and score the video quality. It is the most reliable way how to determine the video signal or the video quality, but the big disadvantages are that these methods are time consuming. So because you have to bring people to the laboratory and make each person has to make a test session, and it lasts, I don't know, 30 minutes for one person, and you have to make, for example, for one testing 15 people, so it is very time consuming. But as I said, it is the most reliable way how to determine the video quality. The subjective assessment is affected by many things. For example, individual interest and expectations. It is a little bit psychological because, for example, if men will watch some soaps, they will rate it maybe with love values. And exactly when women, for example, will watch football, also they will, if it will be good quality, they will rate it with lava values because they are not interested, for example, in football. So this is a little bit psychological, but also affects the video quality, yeah, individual interest and expectations. Then the second is, for example, display type and properties. Yeah, we have many types of displays. So also the display, the brightness of the display, and so on, affects the video quality. The same is the viewing conditions. So, for example, it depends on the room, on the lighting in the room, and so on. Then the fidelity of the reproduction, of course, and very important thing which affects the subjective assessment is accompanying soundtrack, the soundtrack, yeah? But in our case, as I said, I focused only on the video quality, so I didn't take into account the soundtrack. These text sequences were only video, not video and audio together. The subjective assessment from the recommendation ITUR BT 500 is said that for the reliable values, minimum 15 observers has to be used. I think for really good values, we must have about 50-80 persons for testing. The subjective assessment should do only non-experts, so the people that are not interested in this domain, video quality, so the people. And before the test session, every human, every the people should be introduced to method of assessment, so the type of metric, types of impairments that will be in the video, grading scales, so the how the people give the marks to the quality, the sequence and the timing. So, for example, how long will be the test session last? Subjective assessment. The test session should last or must last maximum 30 minutes. First, the train sequences is used. Then there is a break for some questions that give the observer to the people who score. Yeah. Then the stabilizing sequence is done, and then comes the main part of the test session. After the test session, the mid-opinion score is calculated, and also the confidence interval, so statistical parts of the results. We know many subjective methods, and I divided it two parts or four parts. It depends on how I see on it. First, if it is one stimuli, that means if I see only the reference sequence and I don't know how looks like the reference one. So this is, for example, SSCQA, and also the second dividing is if I assess the quality during the presentation, during the watching the sequence, or after that. Yeah, so if it is one stimuli and I assess it during presentation, it is this type of sequence, so single stimulation for quality, for continuous quality evaluation. When I use double stimuli, so I see the reference part and also the test one, I use this type of subjective metric. And these two, as I said, are the metrics for assessing during presentation. But in our case, we used metrics that evaluate the video quality after the presentation. So it is for here should be after, not during, but after. Yeah? Assessment after presentation. So I see and then give a mark. And we know three or four these types of metrics, and I describe these metrics in next slides. So, how was the subjective assessment done? So the process was the same, but only 5 types of bitrate were used: 1, 3, 5, 7, and 9, and 3 types of subjective metrics were used: DSIS, DSCQS, and ACR. So for our evaluation, we used 30 observers. So we made it 2 more than the recommendation is, or as it is written in the recommendation. As I said in the recommendation, is written that minimum 15 observers should be used. So we used 30 observers. The age was from 20 to 28 years, so the mostly students were assessed the video quality. Average age was 22 years. 6 women and 24 men. Here you can see the print screen or the photo from assessing the video quality in our laboratory at our department. The first one, metric that we used is subjective double stimulus impairment scale. In this type of metric, 2 sequences are shown to the observer: the reference one and the test one. The observer is informed which is the reference one and which is the test one. Yeah. So first, it is it is shown the reference one, then the test one, and then comes the voting time. Yeah. So the observer votes or give the mark from this grading scale, from 1 to 5, and the observer watch the differences between these two sequences. So if these differences were imperceptible, gives the mark number 5. That means the best one, yeah, as in Russia. When gives the 1, it is very annoying. So the difference between the reference and test one was very high. This is the first one. Here you can see the results from these measurements. So for basketball and for cactus type of sequence, you can see that as we assumed, for increasing the bitrate, the people rate the video quality better. Yeah. Here you can see the mean values. Yeah, this is the mean score. The mean values from 30 observers from 1, 3, 5, 7, and 9 bitrate. You can see that the difference between 1 and 3 bitrate is a little bit high, of course. So that means the people watched and saw the difference between 1 and 3 megabit per second. Here the difference between 7 and 9 is not so big. Yeah, the marks are similar to each other. The next metric, subject metric that we used was double stimulus continuous quality scale. It is a very similar metric to DSIS, but similar is in the fact that also two sequences are shown to the observer, the reference, the test one. But the difference is that the observer doesn't know which one is reference and which one is test one. So he is not informed about this process, and the sequences are presented randomly, as I said. Yeah, so it is A, B, and B, but or A, B. It depends on the type of this measurement. We can play it one more or two more or two times, one time or two times, but he doesn't know if A is the reference and B is the test one, or B is a reference and A is test one. And also the grading scale is the same. Bad 5 or excellent 1, good 2, fair 3, poor 4, and bad 5. My number 5 mark. Okay, so here you can see the results. The result was a little bit the same. So the difference between these bit rates was high, and between 7 and 9 not so high. The last one, subjective metric that we used, was absolute category rating. This one is a non-reference metric. That means the people are not informed how the reference sequence looks like. So they only see the test one, yeah, after the compression, and they give the mark to the quality. Yeah, so it is played the test one, and then it is time for voting. The marks are also the same, and here you can see the results. The results are also similar, yeah, to metrics that we used before. Why we did this? First, we computed the correlation by using Pearson correlation coefficient between each objective and each subjective method that we used. For us, it was a little bit, not so little bit, but high surprise that PSNR correlated well with the objective with the subjective methods. Yeah, because in many papers it is written that PSNR doesn't correlate well, but here you can see that there are not so many differences between these three metrics. A little bit surprise for us. And according to this fact, yeah, this is the table from measurements that we did 2 years before by using H.264, and here you can see that, as I said, that for example, PSNR doesn't correlate so well as in the table that we have done in these measurements. So, but also the correlation is not the final, the added value that we wanted to measure. This is the added value from our measurement, and this is, as I said at the beginning, that it is the mapping, the subjective metrics, yes, DSAS, the second DS, CQS, and ACF to the SSIM objective metric. Maybe you have the question why I use for mapping SSIM. Because of the fact that SSIM is the only one method that is that has interval. Yeah, as I said, it is from 0 to 1. PSNR, it is peak to signal noise ratio. We don't know if 25 decibels is good and 40 not. VQM the same. Yeah. So because of this fact, I use SSIM. And we can see from these plots or graphs that the people, for example, this is Mark III, that means good. So the people who gave the Mark III said that the sequences were good. And we can say that for SSIM, good is about 0.9. Yeah. So if the SSIM in the other measurements for H.265, of course, compression standard, will be 0.9, we can say these sequences have good quality. Yeah. Something similar is by Cactus. We can see that the Mark III, yeah, is for all sequences in about 0.89. So the difference between 0.90 and 0.89 is not so big. So we can also say that 0.9 is the SSIM value that gives us the good quality. This mapping is very the process of mapping is very necessary for us and for the future, because when we will be able to map any other compression standards, then we don't have to measure the quality by subjective methods that are very time consuming, but we only use the objective. It is very fast, and we can say, yeah, that, for example, we have to have the SSIM minimum 0.89, 0.90, and then we will have good quality in this test, in this video quality, these video sequences. So this is the added value of our testing, and also this is all from me. So thank you for attention. If you have any questions, please ask.